Example number 1 from our textbook. We're going to start talking about transforming functions and relationships. And so basically what we're going to look at is we're going to look at the equation, the absolute value of x, and we're going to subtract 4 from it. Then we're going to look at a second equation, which is y is equal to the absolute value of x plus 2. And before we begin this, in the real world, what we do for math is we look at data, and then we try to figure out what equation fits the data. And then we pick an equation, and then we got to make it fit the data. So the parent function of both of these is y equals the absolute value of x. Now a parent function is the simplest version of an equation or function or graph. And then we got to shift things around to make things fit. So the first thing that I want to do is I want us to graph the parent function and then take a look at it, okay? Actually, you know what I'm going to do is I'm going to use a different grapher. I'm going to use the grapher on my website because it does the graphs in different colors, and maybe that'll be a little more helpful for you guys to see. And so I'd like to graph the absolute value of x. Alright, and so let me fit this in the screen a little better. So that red line is the parent function, the absolute value of x. Now, I'm going to graph the absolute value of x, and then I'm going to subtract 4 from it. So notice that right now the blue line is right on top of the red line, right? So now when I say subtract 4, watch what it does. Now if you were to tell me in English, what did it do? Yeah, so what that means is, what we've just discovered is that this negative 4 shifts it 4 units down. Okay? So now let's go back and look at our graph. Now what do you think would happen if I change this negative sign to a plus sign? That's weird. It takes a second. All right, that's what I wanted. The calculator was giving me a little bit of a problem there. So if I change that to a plus, what does that do to the graph? It shifts it up. So if what we're really looking at then is that if you have this term outside of the brackets and you say plus or minus 4, the minus sign shifts it down. But if I say plus, it shifts it up that many units. Okay? Now what do you think happens over here with x plus 2 when I put the number inside the bracket?
To the left?
Yeah, we would think maybe that it would move it to the left or to the right. So what I'm going to do now is I'm just going to delete this one, and I'm going to graph another one, and I'm going to say the absolute value of x plus 2. And so this looks like it shifted it 2 units to the left. Okay? So that shifted it 2 units to the left. So if I come in here, this plus 2 inside the brackets moves it 2 units to the left. How could I move it 2 units to the right? Huh? So we'll try to subtract it. Now don't write that down yet because I'm gonna show you something here in a second. I'm gonna show you a formula. So when I come in here and I look at the graph, if I change this, what you guys are saying is if I change that to a minus sign, it moves it 2 units to the right. Now what your textbook says in formal notation, it says for horizontal translations, now, do you guys remember what translation means from geometry? It means we just slide the function. If I say we start with y equals f of x, and if I say y equals f of x minus c, then it's going to go c units to the right. If I say y equals f of x plus c, then it's going to go c units to the left. So that's this example here for the horizontal translations. Now for the vertical, it's a little easier. If I say y equals f of x, then y equals f of x plus c is c units up or down? Up. And if I say y equals f of x minus c, then it's c units down. Does that make sense? So that's how Mr. Adams can kind of graph these things in his head because I've memorized these. Okay? So what I do is I just memorize the parent function. Then when I look at it, I would say, okay, I move it over this many units and I go up or down so many units. So this isn't written in your book, so I want you guys to write this down. If I were to write an equation, y is equal to the absolute value of x plus 3 minus 2, how would you graph that? Well, what I do is, first thing I got to do is start with the parent function. So on the xy plane, the parent function of y equals the absolute value of x just comes down like this. What information do I have here that can help me? Well, what I like to do is I like to start at the vertex. If the vertex is here, what does the plus 3 mean? The plus 3 means that I'm going to go 3 units to the left because it's inside the parentheses, and we always do the opposite direction if it's inside the parentheses. So I'm going to go over 1, 2, 3. So this vertex, this V part right here, is now moved over 3 units to the left. Now what does the minus 2 tell you? To shift it down 2 units. So I'm going to go down 1, 2. Now everything else kind of stays the same. So it's the same graph. I've just shifted it over. How do I verify that? Did Mr. Adams do it correctly? I think I did. We can verify it though by looking on the computer, right? So let's graph this bad boy. So the absolute value of x plus 3, and then minus 2. And what's cool about this calculator is you can see how it transforms the graph. Was Mr. Adams correct?
Yep.
Yeah. That's it.